So one thing you might want to practice is just looking back and seeing if you can remember what each of these are. I won't do them again for you because they're all up here, so you can always check. But yeah, have a go at just drawing some of these ones over here. All right. What I am interested in though is describing the shape and modality. Yeah, because something like this, you can see here we've got these histograms now. We don't necessarily have those distributions, but we can also describe the shape and modality of them, right? So this guy here, that resembles our normal distribution or symmetrical distribution. And there's only one kind of peak, so we say that's unimodal, right? Now for the second one, because there's two peaks, then I can say that this one's bimodal. Now typically we don't comment on the kind of skewness of bimodal, multimodal distributions, but if you were to say one, I guess it would be pretty symmetrical as well. So, I mean, we could say symmetrical. C is like a bit of a trick question, to be honest, because they all have the same frequency. So this is actually a special type of distribution. It's called a uniform distribution because all the values are actually the same. Yeah, not to be confused with unimode because there's definitely more than one mode, or the alternative. Go again. So this one has a uniform distribution. Now the question is there many modes or is there no modes in this case? And I guess it depends who you ask. They probably wouldn't ask you something like this because it's actually a little bit ambiguous. The general consensus is if there's a lot of different values with the same amount, then we say that there's no mode. So we can't really comment on the modality there. But I guess in terms of the distribution, I guess you could say it is symmetrical as well. Okay. And last but not least, we've got this guy over here. So remember, draw up your negative and positive signs again, just to work out where the tail end is. And the tail end is over here, right? So that's going to be negatively skewed. And there's only one peak, so then that's just unimodal. Okay, so here's a few different types of questions that they can incorporate. The distributions aren't just reserved. Now, so here's a few different questions that we can have a look at. Now, just to note, the descriptions of data sets for the modality is not necessarily reserved for those particular graphs, right? We can even do this for a box and whisker plot. And the way you want to think about it for a box and whisker plot is what do each of these sections represent? They represent 25% of the data set. So even though this like third section here is a lot longer, right, that still only represents 25% of the values in between 160 and 190. So think about what this is going to look like if you drew the distribution, right? Because you've got 50% of the data between here and here, they're all going to be kind of squished in between. I don't know exactly where the peak is going to be, but since I know that half of the data set falls in between here, and the rest of the half falls between 155 and like 200, then I know that it makes sense if it looks something like this, right? If I squish them all in, and then the rest of the 50% is kind of spread out, and then there's like a tail end towards there. I've got the negative side here and the positive side here. So what's my skewness? Well, the tail end is this side, remember. So the tail end is to the right side, to the positive side. So that's where I determine its skewness. So it's positively skewed like that. Okay. All right. And I guess another way they make things tricky is they start incorporating different concepts, right? So now we're not only looking at skewness, we're looking at standard deviation. Okay, so we looked at that last lesson. And I guess it's really important to just make sure we're confident on those definitions before we jump into it. Positively skewed, I'm looking for a tail to the positive or to the right side. Yeah. And smaller standard deviation, it means it's less spread out. So I know what that means in terms of a numerical sense, like the numbers are closer together, they're less spread out. But what's that going to look like from a graphical distribution perspective? So just think about that carefully. Yeah. Well, let's use our process of elimination though. If it's positively skewed, I really only have two options. I can get rid of A. That's right. Yeah, I can't speak. I can get rid of B and D because they are negatively skewed. Their tails towards the left. But out of A and C, pause if you didn't have a thing. Which one do you think it's going to be? It's not B, by the way. Can I just rule that out? Okay, how do we represent things that are less spread out? Let's look at this by labeling that the fact that the vertical axis, the y-axis, is talking about the frequency, right? So the difference is that C has a much higher peak than A. So I want to use the fact that the vertical axis is talking about the frequency, right? How often a particular value occurs. And the other key thing is that another way of saying less spread out is just more clustered. They're closer together, right? So which of these represents values that are closer and bunched up together? Well, if you think about it, right, let's have a look at C, right? If I think about these values that are centered around here, let's say that that peak is like 5, for example. So I know there's lots of 5s. And I can see around it, there's still quite a high frequency. That means there's lots of 5s, there's lots of 6s, and 4s, and so on and so forth, right? But after a few different values, it starts to drop off very quickly. There are still some values leading up to 100, but then there's not very much. Compare that to this one over here. Although there is a peak here, okay, we could say that that's 5 as well. You can see that the peak is not as high. And what that means is that there are a lot more values down this way as well, right? It's a lot higher than those other sections on C. So if I'm looking for values that are less spread out, or another way of saying that is more clustered together, then C is the answer I'm looking for. So that's just a little bit of a look at modality and the shape of a distribution. Hope that helps.